On the night of July 19th, 1952, something rather strange happened on two fronts in North America. At Mount Palomar Observatory in Southern California, a pair of photographic plates were taken about 1 hour apart, one just before 9 p.m. and the other just before 10 p.m. local time. In these plates, one showed a cluster of 3 star-like points, essentially indistinguishable from stars. But in the second plate, the points had abruptly and inexplicably disappeared. Known as transients, these short-lived events hold much promise in the study of astronomy, in that they show events in much shorter timescales than astronomy normally looks at, a known deficiency for many years. What these 3 star-like points represent is an open question, with potential answers ranging from gravitational lensing to short-lived astronomical phenomenon we currently haven't thought of. They do not appear to be plate flaws or contamination, however. Those leave telltale signs not present in this transient. Rather, they do appear to have been there 1 hour and gone the next. Interestingly, it was possible to constrain their distance, which turned out to be less than 2 light years away at maximum and within the orbit of the Earth at minimum. Curiously, on the other side of the country, the time the plates were taken would have been between 1 and 2 a.m. on the East Coast. At the time, one of the most puzzling UFO flaps in history was happening in the Washington, D.C. area, including multiple radar returns and visual sightings from people in several locations. Coincidence perhaps, but all options must be on the table when trying to figure out what that telescope at Mount Palomar imaged that July night in 1952.
You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Dr. Beatriz Villarroel. Dr. Villarroel studies astrophysics and astroparticle physics as a Nordic Fellow at Nordica, the Nordic Institute for Theoretical Physics. She has served as the lead on multiple papers using existing survey data to find examples of exceptional astrophysical transients, including looking for physically impossible effects caused by highly advanced technology.
Beatriz Villarroel, welcome back to the program.
Thank you. It's a pleasure to be back.
Now, in our long-running series on transients, you now have a new paper on a newfound transient in a photographic plate taken in 1952 at Palomar with, I assume, the Hale telescope, which at the time, that was the most largest and advanced telescope we'd ever built. It was state-of-the-art. And yet, there's this transient there where in one plate you see essentially 3 objects that look like stars, and then a plate an hour later, nothing. They're gone. Tell us about this new paper regarding this particular transient.
This is a new paper that is actually led by my colleague Enrique Solano at the Center of Astrobiology in Madrid. And he has discovered this image where you see 3 very bright and beautiful stars. And they are there in that unique plate, but you cannot see them ever again, not even 1 hour later. And these 3 stars we wanted to find with the largest optical telescope because we thought maybe they just got much fainter. So we used the Gran Telescopio Canarias, which is a 10.4 meter optical telescope, and we looked there, we went very deep, and we found nothing. So they really vanished. And they look real. And it seems to be like another case of the so-called multiple transients that we've been seeing before.
Now, you've written previous papers on this where there are other transients. What makes this one, and I actually know the answer to this question, but what makes this one especially compelling?
It's so bright, so beautiful, so star-like. Because with the previous ones, like when the first case we found, they were very faint. We were wondering, okay, maybe it's some kind of plate flaws that have some very unusual, coincidentally star-like shapes. But again, they were quite faint and close to the detection limit. And now you see 3 super beautiful stars that are there and later vanish. And that is the kind of thing that we reacted on.
So what magnitude are we talking about as far as brightness goes?
I think 15 mag, more or less.
Which for that telescope, that's solid. I think what could a telescope like that?
15, 16 mag to be more exact.
Yeah.
But it's solid.
And they all appear to be the same brightness?
More or less, yes. It's a little bit difficult to get the exact magnitudes of the two ones that are in the crowded region because they are like overlapping. But they seem to have the same, more or less the same brightness, all three of them. Maybe the one in the back is slightly fainter also, but yes.
What strikes me about this is that does not look like a plate flaw. That looks like stellar objects. And that should be there set in stone, so to speak. But that's not what this is, right?
Exactly, because when you have something very faint, you can always try to say that it's a plate flaw, and then suddenly you have these three like super clear stars, and they don't look like plate flaws. But of course, we will always find someone who is going to say, but it probably is a plate flaw. And I think that is why we need to confirm this phenomenon with entirely different methods that have nothing to do with photographic plates. But yeah, they look very authentic.
Now, in your work, you look at photographic plates, and I'm sure you see plate flaws and the characteristics of them. So what does a plate flaw actually look like usually?
No, but plate flaws usually looks like random shapes, lots of random shapes. So in order to get to look like stars, you would need to have a very specific, it would have to, a lot of different factors would have to align up, if we say like that, to make it look like a real star. So I think it's a very, very improbable event. And now to find several of them that look like stars is even more improbable. So that's the thing. And I would also expect that if you have, let's say, 10 very bright plate flaws in one plate, you would see some things that are a mix of different forms, but not that it would only look exactly like the stars in the field. So I don't know if this rant made it clearer.
It did. Now, what about exposure time? In other words, how long was the shutter open on the plate that shows the transient? How long was the shutter open to, sort of eliminate any movement that might be there? Because they appear to be point-like.
50 minutes.
Yeah.
It's a 50 minutes exposure time. So if something would be moving in and out of the image, it should be leaving an elongated streak. It's not going to be, let's say it moves fast. If it moves fast during this 15 minutes, so fast that it can go out of the plate and move somewhere else, you're going to have a streak, not a point source. Now, if it moves very, very slowly, then so slowly that it leaves a point source in the red image, you would also see a point source in the blue image that is taken 1 hour later. But you don't see that. What you see is really a point source only in one image and nothing in the other. So how does that happen? That is a question.
Yeah, you have to wonder that, stars don't just disappear. They don't blink out, or well, at least as far as we know. Hopefully, well, what about things like a really, really weird event, like a gravitational lensing effect? In other words, a naked black hole passes by lenses some normally very dim stars that are out of the reach of the telescope, and you see them very briefly. What about natural, weird things like that with especially gravitational lensing?
So we've been thinking about it for this particular case, because imagine if you have this gravitational lens that is very, very massive, and suddenly behind this lens you would have a short transient, something that flared up just for a few minutes. Maybe what you would see as an observer would actually be that you would see this transient through the gravitational lens, and it would give multiple images. This is one of the thoughts we were having. My colleagues estimated what would be the possible mass of the lens, and they concluded something like 10 times the Milky Way mass. 10 times the mass of the Milky Way black hole. And I'm not sure. We are not gravitational lensing experts, and I don't know if this is a reasonable or not reasonable scenario.
It has to be said, though, looking at the image, it does look like an Einstein cross, you would expect. But at the same time, when you see those, it's usually the entire mass of a galaxy bending that light and making that effect when you see it with like a quasar or something like that. And it would seem to me that, that's an implausibly huge black hole to be not at the center of a galaxy. But it's you have to look at all angles and see what might be there. Now, what about other options with this? What other ideas have you guys come up with that might explain this?
Well, I still think that there is an option of that we are seeing something, either some reflecting the sunlight, or that you see something with its own intrinsic light that is fairly close to Earth, why you see it like happening at the same time. Because, the speed of light is limited, so it's not going to come from a galaxy far away, but it's likely to come from inside the solar system.
Though you gotta wonder though, if it were like an asteroid or something like that had varying albedo and you just happened to catch it, but how did it happen that it had 3 lobes? It just seems...
No asteroids. Well, I'm thinking more about maybe something artificial, possibly, as a possible hypothesis. Something with either, again, its own intrinsic lights or lamps or something, or maybe something reflecting the sunlight, and let's say something very flat, very like glass or metal or so.
There is an elephant in the room. This plate is from July 19th, 1952, which is the evening that a massive UFO flap happened over Washington, D.C. that was caught by multiple radars.
It's quite fun, a coincidence, right?
It's quite the coincidence, and it has to be said that did happen. And maybe I would dare say, though, if that's what this is, a photographic plate from the Hale telescope at Mount Palomar Observatory would constitute probably the best UFO photograph ever taken, right?
There is something even more fun about this. When I discovered, or actually I didn't discover it, when my friend Dave Altman pointed out this date, because it was he who recognized the date when I mentioned like 19th of July 1952. After he had pointed it out, I was wondering, hey, what about the dates of my other candidates? And I went to this paper where we had been looking for alignments. It's a paper called like, is there a background population of like high-albedo objects? I don't remember the exact title, but last year we put it on archive, and it's a paper that has issues getting published, because it's a little bit too transparent, I would say, about the alien angle. And we had 5 candidates, where there were 2 that were statistically significant and 1 that was the best of all. And in the one that was best of all, you could see 5 objects in a line. And it was called Candidate 5. And if you look at that one, that is from the 28th of July, 1952, which is like also inside this time region of the Washington flap. It's one day after the second weekend, I think. I think the second weekend was 26th to 27th of July, and this one happened on the 28th, and I found it super funny. I like that kind of funny coincidences.
We have to remember, too, that this is before satellites. So this is before Sputnik. So we had nothing up there. And I mean, at that time, 1952, we were still experimenting with captured V2 rockets and things like that, and developing further rockets. And we just didn't have the technology to put something out there that would explain this as human interference, so to speak, right?
But what if there were some secret military experiment that resulted in the Washington flyover, but also resulted in that they created some kind of very radioactive particles that were just captured on the plates those nights?
Oh, that's interesting. So there might have been a secret nuclear test that might have done it, that we could do, because remember, obviously, World War II and Trinity testing, and that maybe there was something thrown into the atmosphere that was... But couldn't you look at other photographic surveys and look for the same thing, reoccurring?
Maybe we could actually look for the photographic surveys that are from July 1952 and see if we can find more signs of, let's call them UFOs, or any kind of UAPs, or it's a possibility.
Unidentified astronomical object. I'm coining a phrase. Yeah.
It's an interesting coincidence, and of course it has made me wonder even more.
Now, what other photographic surveys from this time period are there? I'm sure the Vatican was doing it with the astrograph that they had. So what other sources of data can you look at?
Maybe the Lick Observatory could be a good... Well, it could work. Unfortunately, the Harvard plates don't seem too accessible. There are photographic plate surveys, I think, from Ukraine, but I don't know if they have the 1952 year.
Now, what's the future? In other words, we've got really ideal-seeming survey telescopes coming online soon, probably the biggest being the Vera Rubin Observatory. Are you thinking in terms of searching modern data sets like that when we get it?
Actually, we are going to try to go a little bit ahead and create our own project called Exoprobe, where we are going to create like where we're going to place multiple telescopes. And they are all going to be filtering away human space debris and human satellites. And we're going to search for this kind of multiple transients, but also search deliberately for signatures of ET probes or unidentified objects that are leaving short transients. We're going to really focus on transients in these searches. And the goal will be like if you use multiple telescopes, then if you see some very short flash in several of them, you directly know that it is a real observation and not something on the plate. Or sorry, not something just in one image. I'm still saying plate.
Independent telescope corroboration of a transient would be amazing.
That's exactly what we want to achieve. And then at the same time, if you use like, let's say at least 2 telescopes, you can triangulate and you will directly say like it's at this and that distance. And now if you use 10 telescopes, you will get a very accurate distance because you can get the location, the 3D location much more accurately if you have many more combinations of triangulating.
Within the question of technosignatures, there is a known bias, and Dr. Sean Kirkpatrick recently stated it as the orbit of Mars. A technosignature outside of that can be talked about, like a von Neumann probe or something like that at Jupiter. But when you start talking about anything getting close to Earth, the biases come in, even though it's virtually identical. There's no difference between a von Neumann probe in orbit of Saturn or one in Earth's atmosphere. What's your view on the stigma, and how can we sort of try to get past it?
Well, actually, I find it pretty fascinating that there is such a stigma to search near the Earth, because technically, why wouldn't a probe that can make it into the solar system make it also inside the atmosphere?
There's no difference.
There's no difference. So this is just like some kind of social barrier or so. And I think the only way how we can get past that is by doing these searches and show that, okay, we know there's a social barrier and we know that it's going to be difficult to publish the papers, but we will still look. And even if we don't publish them right now, we will probably get them published in a few years when the stigma is off and people will be kind of much more open-minded. Simply go on and do your best. That's all what one can do.
The other thing is that, you have to ask another question when analyzing this sort of thing, is that, again, we've talked about von Neumann probes and we've talked about Benford probes and Bracewell probes and all this sort of stuff that could be in the solar system, artifacts on the moon or whatever. Yeah. But we ignore the fact that we might be living on the most interesting planet in this star system.
Yeah, why wouldn't they send it right to the Earth? And I think this is the best place to send any probe to. So if I would be aliens and I would know that there's an advanced civilization here, I would send all the probes here and I wouldn't send it somewhere else.
The universe is full of gas giants and Venuses and Marses and things like that, but not so much with civilizations as far as we can tell in SETI. And that it seems to me that bias, the Mars orbit bias, is just really unhelpful because the Earth's atmosphere is where you would expect to find a technosignature, if there is indeed an alien civilization here studying us.
Exactly, and this is where you could imagine that you would see things like artifacts and remains on the planet, maybe in geological records even or so. So I think it's a completely valid way of starting SETI searches here, and simply assume that if we can send something to a different stellar system, also can another civilization send something to us and to the Earth. So I'm totally in favor of this type of SETI.
I also am attracted to the idea of searching the surface of the moon for any evidence of a past visitation, just because the moon, unlike the Earth, the moon does not recycle its surface constantly. And I think that that's kind of a wide open area for technosignature searches, is to start looking at lunar maps and things like that might reveal something that was once there.
I think that's a really, really beautiful idea. And I think there are even some searches, like AI-driven searches for artifacts on the moon, led by ETH researchers in Switzerland. By the way, I apologize in case you hear weird sounds from my end. It's my cat coming here and licking my plate that had some ham on. So sorry for the weird sounds from my end.
Oh, it's quite okay. We like the cat. I like cats, and One of the reasons why I have a separate Event Horizon studio for my house is that my cats will try to talk into the microphone.
And this one might try to. It's a non-human intelligence that is trying to find her way of maximizing her resources. So
Yes, a von Neumann cat.
exactly. I completely agree with you on your entire assessment, both about the moon and about the Earth, and I hope there will be more set in that direction, because we have been doing 60 years of radio searches, over and over again, always pushing the limit. But if you do something over and over and over again and you don't get any results, it's maybe time to open new doors, because new doors will always lead to something unexpected, even if it's not what you were looking for.
Well, if you're going to look in radio, then it only makes sense, and this has been something that's been changing recently, is if you're going to look in radio, look everywhere. Look at every possible technosignature you can think of and see if it might be there or it might not be. And that's one thing that I think there's not enough work done on is sort of the candidates like Jabilsky's star or HD 139139, where we don't exactly know what it is, but as soon as it looks weird and potentially alien, all work on it stops. And I think that now is the time to change that and take a fresh look at these weird potential technosignatures.
I agree. I think there's an experience that a lot of astronomers have at some point, which is like the driving force. Let's say you're young and you discover some anomaly, and you get super excited, like this coolest thing ever, this anomaly, and you invest months into exploring it, and then in the end you discover that this was something super mundane. And then maybe again some time passes and the same thing happens. And I think what happens is that lots of astronomers develop over time, some type of experience of that when it's an anomaly, 95% of the time it's something mundane. And since they want to publish and make good careers and do serious science in quotation mark, it means that anomalies very often get overlooked, because people assume that, it's going to be 90% probability of that this is something boring and uninteresting or instrumental, and 10% probability that this is something real. I better take a more safe road and I go for more safe science. And in that way, a lot of anomalies remain unsolved. While I think the most fun thing is actually to explore anomalies. If we don't do that and stay on the safe side, sure, we can learn a lot, but it's not going to be as intriguing and as adventurous as the more risky road.
It's a high payoff, though, because if you discover an alien civilization, you've just made probably the biggest scientific discovery in the history of humanity, that we are not alone.
But what if there's something even crazier than an alien civilization? Something even crazier to be discovered that you cannot really imagine right now, but you would discover it and it would make the alien civilization look like a mundane explanation.
None of the above. In other words, it's something, but it's not an alien, but it isn't from here. Well, that requires paradigm changes, but paradigm changes are common in human history. And for example, someone in the medieval world had no idea quantum mechanics existed. And maybe this works like that we just have no conception of what might be there, and it might be weirder than aliens in the end.
Yeah, and I think there is some kind of idea that I see in a lot of my fellow colleagues, and that is something like that. We have already discovered all the important physics. There is nothing big and new to be discovered, which I find super weird. The first question that hits my mind is, okay, so if you don't think that anything new can be discovered, then what's the point of doing all this research? Well, of course, they will reply that they want to understand the natural processes and into a finer detail and so on, but I find it so hard to, for me, it's a point of view that is very different from my own, because if you look at physics, most has been done in the last 200 years. And what is 200 years in the history of humanity? It's a short time period. And now imagine you have some civilization that has been there for 1 million years. I think they will know so much more about physics than we ever, or that we will do at this point, that I think there's an immense world of discoveries ahead of us, ahead of the humans, and it would be so cool to be part of that and see some of it.
The thing is, though, is that the universe throws curveballs, and we see hints right now of a fifth force, and things like that, and maybe another planet in the solar system, Planet 9. We see all these indicators and things that change our paradigm, and we need to be prepared for that. But in defense of science, most scientists I've known actually really get intrigued when there are discrepancies, hints of new physics and things like that. So at least there still is an open debate. It's not a dogma. It hasn't descended completely into a dogma yet.
I think so too. You're right. Maybe I was thinking a little bit too dark, and I just remember a couple of conversations sometimes that stuck in my mind. You're right. Many scientists are very excited when there's some new anomaly.
Well,
I remember people were super excited when there was this neutrinos traveling faster than the speed of light at CERN.
I remember that. Yeah, I remember that. And it turned out to be a bad cable or something. But
that's yet another example of when anomalies turn out to have some very mundane explanation.
It's true that you can have, misinterpretation and knowing that your data may be flawed. And, there's all kinds of things you got to go through the whole list to make sure that, confirmation bias, all of these things to make sure that what you're seeing is real. But that's what peer review is for.
Exactly.
So what's the future look like on looking at photographic plates from the past versus looking at new data, new data sets from telescopes like the LSST Vera Rubin Observatory that's going to come online? Can you use computers and things like that to automatically look for these kinds of transients and see if they're still occurring?
Actually, that's exactly what we want to do, but we want to build our own system to look for these kind of transients because we think that they are quite short from what we're seeing with these plates, that you can only see them in one plate. So what we want to do is to create a system where you have multiple telescopes, where you search for short flashes, and you only retain the flashes that are seen in at least 2 telescopes to make sure that they are authentic. And when you have multiple telescopes, you can also, let's say you have 2 telescopes, you can measure the parallax to an object inside the solar system. Let's say that this flash comes from something that is blinking or having some laser. By seeing the flash in 2 telescopes, you will, once you have the parallax, you can get the distance. And now let's say you have 10 of these telescopes and you see the same flash in all 10 of them, then you're going to have a very good accuracy on the distance to that object. At the same time as you are validating the flash and you know that it's real, at the same time as you get the 3D location, you can actually also use a so-called wedge prism in order to measure, get a spectrum in low resolution of all the objects in that field. That is what we're going to do, try to get the real-time spectrum.
When you get a spectra on a transient like this, say you catch one and you catch it in multiple telescopes, so you know it's really there. It's not a plate flaw or anything like that. It's really there. And you get a spectra on it. What happens if that spectra is not that of a star?
Well, it depends on what we actually see, because maybe what we are seeing is some kind of communication laser that looks the same as what humans use in their communication satellites. Maybe also the object that we are seeing is in geosynchronous orbit and moves just like a human satellite and shoots a laser just like a human satellite, and there is nothing that indicates any kind of anomaly. Then it's not super exciting. But what if that spectrum, what if you know that object is something that is very close to the Earth? It moves, let's say again, at the geosynchronous orbit, but what you see is not any laser and it's some very peculiar type of emission that you've never seen. That would be super cool.
Now, how would you go about the process of elimination to begin to ask? In other words, if it's a technosignature, then it could have a signature that is, there's no way that can be natural, right?
Yeah.
And so you say, like with a star, when you see a star spectrum, you see all the absorption lines and all this stuff. And if you don't see that, I mean, it would seem to me to be a very fruitful method of SETI to start looking at these transients and try to catch spectra.
Well, we have our methods that I cannot reveal yet in the ExoPro program, where we'll be removing all the human objects like space debris and satellites. And we also are working on establishing a protocol where we remove the remaining unknown objects. So, of course, there's always a chance that you find some very anomalous thing that is some very secret experiment that some country on Earth has sent there. But I think we know the boundaries of what humans can create and produce, and we will have to check whether the anomalies are within them or outside them.
Yeah, that's going to be a problem because that's a thing in satellite technology, is blinding other satellites, meaning you're emitting some kind of light to throw off the rival satellites and things like that. Now, what about, will this research result in other discoveries? In other words, might you find, when you're looking for your transients and taking plates with this many telescopes, might you find something like, I don't know, Kuiper Belt objects or Planet 9, something like that? Could you catch that with this survey?
I think there's a very good possibility that you can find some very unusual astronomical phenomena that are just happening on these short timescales, because in the timescales we are focusing on, very few astronomers have examined it. And that's what makes it so exciting. And that's why it's so fun for us to explore it. And by the way, just a small thing I was thinking about in connection to the previous question. One more thing, by the way, in the way how we can separate between human objects, even the secret ones, and the non-human objects that we are interested in, the artificial, let's call it ET probes, is that we are going to actually search quite far away from the Earth for starters. Because in that way, we get rid of all these satellites at low Earth orbit, and we get rid of the whole belt of human space debris. So it's a very good thing to try to start and the searches further out, because there, everything that has been, or most of the stuff that humans have sent, are very well known.
So in other words, we know what the signatures of human technology are, and we should be able to tell that from alien technology. For example, if you were seeing, say, the light from some kind of a photon drive or something like that, it would be so characteristically weird that it can't be something that humans produce, right?
Exactly. So that's how I'm imagining that you can identify some of the unidentified objects. Or if you find, let's say, something that maybe looks more like a conventional ET probe, but in completely wrong place. No country says that they have sent their space rockets, and it's too far out to just be a random object that is there that nobody knows what it is. That's also a possibility.
Now, you can use parallax to determine that distance, right?
Of course.
When you're using multiple telescopes, and you can determine that this is either close or far away.
Exactly. And that's what we want to do.
So where are the telescopes going to be located? I mean, is it globally, or what telescope locations are we looking at?
So actually, we hope to get it globally. But in the first phase, it's going to be in California. So we're looking to put up a telescope there in Sierra Remote, and also 2 more locations. So that's where we are now. We are trying to solve the administrative things with the telescopes.
What kind of telescope apertures are we looking at? What are the size of these telescopes? It would seem to me you can do this with very small instruments, right?
Exactly. We are going to go for very professional, state-of-the-art half-meter telescopes that have super good tracking and very good mounts that are reliable to do this type of work. And yes, they are pretty expensive, so of course we have to work on that end to make it happen. But these, we're imagining at least 3 telescopes in California, and hopefully within the near future. So one is being ordered, and there are 2 more not equally good as the one that we're ordering, and one that also one of them actually recently had an accident, so we need to solve that too. Yeah, there was a little accident that happened with one of them, and we will need to replace it.
Now, this also seems like something that citizen scientists might be able to do, look for transients, because there are a lot of people doing astrophotography out there, and there have been for decades, and that maybe people that have archives should look and see if anything's missing in their photographic plates that they have, and let you guys know about it.
I would love if they did that. And we also have a citizen science project that we've been running with the Vasco team, where people can go and actually search for this type of objects that are vanishing. We're now actually wrapping up the results from there, and we found some thousands transients. We didn't find any example of a star that is there in 5 places and later vanished, but we found many of these short-lived transient things. So everyone are welcome to help us with it also. Or they can also do it with their own telescopes and their own archives. I think there's a lot of potential when it comes to transient searches, especially in the short time region.
Now, you recently spoke at the Seoul conference, which was put on by Gary Nolan, and regarding the UAP. Tell us about that.
Oh my God, that was the most interesting conference I've been to probably in my life. So fun, so nice people, so brilliant thinkers and minds, and such a diversity in the type of work people are doing, and still there's such a unity because everyone wants to understand the phenomenon or the UAPs, or if there are ET probes, and this curiosity people had, there was such a passion for the topic. Apologies for the sound background.
That, just for the listeners, that is the sound of a very active cat.
Yes.
All right, Doctor, thank you for visiting with us yet again. And I look forward to the next paper because I'm just fascinated by these transients. And legitimately, this is one of the things that really puzzles me these days in science is these transients, especially this one with the Palomar plate, because it just does not look like, it looks like stars.
Yeah, that's the thing. It's like we have several of these cases with the multiple transients, all look like stars, and some are even aligned, like lying beautifully in a line, like if it was satellites moving and tumbling. And of course, they are from the early 50s when there was nothing human at those high altitudes or in space. So I find it super puzzling. And maybe there's some new physics that I don't know about. Maybe there's some completely different type of explanation. I'm, of course, also limited with my bias, but I find it fascinating and I want to understand more what it is with new projects and everything I can do to solve the riddle.
Natural or artificial, it's going to be interesting.
I think so too. I'm very curious about where it will lead.